Okay, so concerning the absolute value, let's take a look at an example with the absolute value. A simple one, like allow me to choose this time. Okay, it's exactly what we just did, but we have to simplify it ourselves. So this is the integral from 0 to 4 from the absolute value of x minus 3 dx. We talked about the absolute value, and we wrote the formal definition of the absolute value. So again, let's write it again. The absolute value of x is x when x is greater than or equal to 0, or negative x when x is less than 0. This is the formal definition of the absolute value. But what if I have not x, but some other expression in x? It doesn't matter. This and this and this and this and this, they're all the same. So now I can replace them by x minus 3. And I just mimic what I see. The absolute value of x minus 3 is x minus 3 if x minus 3 is greater than or equal to 0, or the opposite of x minus 3 if x minus 3 is less than 0. All I did was I replaced x everywhere by x minus 3. X minus 3, x minus 3, x minus 3, x minus 3. Yes, it needs a little bit of work. I have to simplify it a little bit. So I will simplify it and write is x minus 3 when x is greater than or equal to 3, or negative x plus 3 when x is less than 3. This is exactly what we just did with problems 2 and 3. And now we have on the interval from 0 to 4. Everything is the same. So from here, I'm going to jump here, and I see there is a break at 3, right between 0 and 4. So I have 0 to 3 and 3 to 4. 0 to 3, careful, 0 to 3. From negative x plus 3 dx, and 3 to 4 from x minus 3 dx. Let's stop for a moment and see if you have questions before we continue. We haven't finished, but let's see if we have any questions. Any questions? Okay, so let's finish it up. Negative x squared over 2 plus 3x from 0 to 3 plus x squared over 2 minus 3x from 3 to 4. When I plug in 3, negative 9 halves plus 9. When I plug in 0, nothing. Plus, when I plug in 4, 16 divided by 2, minus 12. Minus, when I plug in 3, 9 halves minus 9. So let's see what we get. Okay. Uh, 17 minus 12 is 5, minus 9 halves, minus 9 halves, and plus 9. So this is 14, and this is 18 divided by 2, so this is minus 9, so the answer appears to be 5. Any questions? Okay. The next set of problems, again, the same applications. We're just looking at different situations. We are given the graphs. They are giving us this graph and this graph. Then they are giving us these two, and they are graphing them. And they shaded in a certain area that they want us to determine. Same thing here. Okay. Which one would you like to work on? which one would you like to work on? Okay, I would choose 12. So the area is given to, the graphs here are given to us and the area is shaded in. So in number 12, we have the blue graph. Let me copy the functions first of all. F of x equals x to the third plus 3x squared minus 9x minus 12, and also g of x, which is 4x plus 3. And they want us to determine these two pieces. Of course, the first piece has the above f of x and the below g of x. But the second piece has the above g of x and the below f of x. So the total area will be the definite integral from -5 to -1, -5 to -1, from above, which is f of x. I'm just going to write it like this first, minus g of x plus the integral from -1 to 3 from above, which is g of x, minus below, which is f of x dx. So the first piece has this above and this below, but the second piece between -1 and 3, those are the points of intersection, -1 and 3 for x, of course, from the above minus below. All I have to do is just plug them in. So this minus this here, and the reverse, this minus this here. And then determine the definite integral. So let's do that. Stop me if you have questions. So I have x cubed, I have plus 3x squared, I have minus 9x minus 4x, which is negative 13x, and then I have negative 12 and minus 3, which is negative 15 dx. Let's take a moment and see if this is clear. So this minus this, x cubed plus 3x squared, minus 9x minus 4x is negative 13x, negative 12 minus 3 is negative 15. Plus the integral from -1 to 3. Now, g of x, 4x plus 3. Maybe I should write this one because it's a little bit, because I have to subtract everything else. So g of x minus x cubed minus 3x squared plus 9x plus 12. Okay, equals. So the first one is ready. X to the fourth over 4 plus 3x cubed over 3 minus 13 x squared over 2 minus 15x, and this is from -1 to -5 to -1 plus. As you see, the repetition in all of these. Plus. Let me write it first, -1 to 3, and we have negative x cubed minus 3x squared plus 13x and plus 15 dx. So in the correct order, descending order, this, and then positive 13, and then positive 15. Same thing. Okay, so I plug in -1, 1/4, minus 1, minus 13 halves, and plus 15. A lot of calculations here. 625 over 4 minus 125 minus 13 times 25 over 2 and plus 75. Okay, one more time just to make sure. -1, yes, that's correct, minus, this is correct, this is correct. This is correct, and this is correct. Okay. Now I'm here, plus negative x to the 4 over 4 minus 3x cubed over 3 plus 13x squared over 2 plus 15x. And this is from negative 1 to 3. I cannot blame anyone. I chose the problem. I'm kidding. Okay. So, 1/4 minus 13 halves, and this is plus 14, minus 625 over 4, plus 125. Oh, maybe I should just do this one. Never mind, I already wrote it. Okay, plus, how much is 13 times 25? Anybody? 325, okay. And minus 75. Let me see if I changed all the signs. This I changed, this I changed, this I changed. Okay, plus. Okay. 81. I need to erase the positive. It's negative. Okay, so minus 81 over 4. Minus 27 plus 13 times 9 over 2 and plus 45. Now minus, when I plug in negative 1, 1/4 with still stays with a minus in front. Positive 1, positive 13 halves, and minus 15. Yes, I know this is a little bit of a torture, but I started it, so I have to finish it now. Okay. -625, negative 625 plus 1 is negative 624. And it's divisible, so negative 624 over 4, I'll get back to it. Minus 13 halves, 14 plus this is 139. Minus 325 with 2. And negative 75 with this. 102 minus 81 over 4 plus 117 over 2 plus 45 plus 1/4 minus 1 minus 13 halves plus 15. Okay. 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 So I have a negative 156 plus 139 minus 102 plus this is 60 minus 159. So I got negative 60 on these. Okay. Now let's see. Negative 13, so this is negative 13. So let's see, negative 35 plus 117, and I divide that by 2. Okay, So these are accounted for. Negative 104. This is a negative 80 divided by 2. So these are accounted for. I think I'm done. Okay. The area cannot be negative. The areas can be negative, but if it's an enclosed area, the answer can never be negative. So if we have this situation, this is positive and this is negative, the area can be negative. But if I have an enclosed area between two graphs, yes, it can be negative, I'm sorry, because there is an area under the graph. Okay, it can be negative. This particular situation can be negative. Okay, good. So we'll check in a minute. So this is 80, this is negative 184 minus 13 is negative 197. So the area can be negative. But I'm inclined to believe that everything was fine. F of x. I'm checking before I enter it and check again. So that was negative 13, correct, minus 15. And the other one was also correct. Let me check the points of intersection one more time just to make sure. Indeed, from negative 5 to negative 1, that's correct. And from negative 1 to 3. Yes, that's correct. Okay. We're going to check right now, but I'm not happy with the answer. I don't know the answer, but it appears to be strange. So it was from negative 5 to negative 1. I'm just making sure that I didn't reverse something. That was negative. This was negative. This was positive. With minus 5, this was positive. This was negative. This was negative. This was positive. That's correct. With 3, negative, 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 positive, positive, and with negative 1, did I subtract? Yes, I did. Okay, when I plug in negative 1, this is negative, this is positive, this is positive, this is negative. It appears that I'm okay, but let's check. Okay, so back to the very first. Be careful when you enter and you check with the graphing calculator. Do not enter the antiderivative. You have to enter the original function. Careful. I'm not saying that you would. I'm just making sure that you understand that. So negative 5 to negative 1. A lot of calculations on this one. So x to the third, and then plus 3x squared plus 3x squared, and then minus 13x, and then minus 15, of course dx, and then plus the integral from -1 to 3. Okay, from, where is my function? Yes, -x cubed, so it's the same thing with the opposite signs. Yes, so -x cubed minus 3x squared, and then plus 13x, and then plus 15, of course the x, and if the answer is not -197, and I didn't expect that to be, so that's why I said it's a, I wasn't sure where my mistake was. Did anyone see anything? It could have been at the very end with all these numbers. Let me just redo the calculation here. So from scratch, right here, without performing anything. Let me see if I did anything here. Plus 14, that's minus, that's plus. That's correct, that's correct. Okay, so I'm just going to redo this. I don't see a mistake, but I didn't like the answer anyway. Okay, minus 13 divided by 2 plus 14 minus 625 divided by 4 plus 125 plus 325 divided by 2 minus 75 minus 81 over 4 minus 27 plus 13 times 9 divided by 2 plus 45, and then plus 1 divided by 4 minus 1 minus 13 divided by 2 and plus 15. And voila. So I have, this is okay, everything is okay. Indeed, I got 128 indeed, but my calculations here, the final step. So this, something is wrong here. That's why I did not expect the area to be that. It's an area enclosed. So it's not referenced to the y equals 0. So it's an area that is enclosed among graphs. So it cannot be a negative number. This can be negative, but the area enclosed cannot be. So I did not expect that to be okay. So everything is okay. Just redo it if you'd like to see what I did here. Something was went astray. So this is the idea on how we calculate areas among graphs. It required a lot of, as you saw, a lot of numbers because of the polynomial function, degree 3. Now, the next set of problems, 15 through 33, we are not given the graph. We have to graph the function. We have to find points of intersection. We have to shade in the area ourselves, and then we have to find it. So let's choose. If you'd like to choose, if not, I will.